Okay, so we're here with NVIDIA and they're about to show us some benchmarks. We're very excited. The moment of truth is upon us. I'm here with Sridhar. He's with Technical Marketing with NVIDIA and he's going to show us a few things that demonstrate the power of the Tegra 4 platform. So I'll let him take it away.
Sure. Hey guys, all of you must have seen the benchmark results of Tegra 4 that was recently published, but many of you may be wondering whether Tegra 4 is really a low power chip, and here I have a demo to prove that Tegra 4 consumes really low power and can fit in phones and tablets. What I have here is our Tegra 4 phone development platform. Obviously this board is really big, it's not going to fit in a phone, and the reason for that is that it's got all these debug ports that our software engineers and our OEM partner engineers use to debug the phone to optimize it for performance and power. And I have hooked up this development board to a power meter through these wires, and this power meter is basically measuring the power consumption of the phone at the battery terminal. Right now the phone is in standby mode and it's consuming less than 10 milliwatts of power. The sensitivity of this meter is like 10 milliwatt range, that's why it's showing 0. But the moment I turn on the display, you'll see it'll spike up a little bit, but eventually it'll settle down to around 0.7 watts. So basically when the phone is idle with the display on, it's consuming only around 0.7 watts. And most of that power consumption is due to the, the display backlight power. Let me unlock the screen here and you guys can take a look at the meter. There you go, the phone is sitting idle, the power is settling down, it comes down to 0.7 watts in idle mode. So let me launch the gallery and play a 1080p video clip. Play, and start over and tilt this board a little bit so that the video comes to landscape mode, and let's let the power settle down. And what you'll notice is this is a 1080p screen. The phone is decoding a 1080p high profile clip, and you see it's consuming only around 0.88, 0.9 watts.
Nice.
When you compare this to a competing system, a 1080p phone like the Droid DNA, for example, we found that the Droid DNA consumes around 1.2 watts. So Tegra 4 is actually consuming 25% lower power than competing systems out there, and it gives you approximately 2 to 2.5 hours more battery life. So you get both high performance, as you've seen in the benchmarks, and low power from Tegra 4.
Excellent. And in terms of the relative performance, a lot of the industry analysts, from what I've read at least, they say that Tegra 4i is not Tegra 4. Can you just speak to that a little bit?
Well, it's not Tegra 4, but performance comes close to Tegra 4,
quite close.
And the user experience is close to Tegra 4. And the reason for that is you can play all the Tegra 4 optimized games on Tegra 4i because it's got a 60-core GeForce GPU. It has the same i500 modem architecture in there. It supports the same computational photography features that Tegra 4 supports, and it's going to deliver great web browsing, great gaming experience, and really long battery life. So in all these aspects, I believe that T4i is much closer to Tegra 4 performance, and clearly it's aimed at the mainstream smartphone market, and Tegra 4 is for the super phone, high-end hero smartphone and tablet market.
Tablets, of course, with ridiculously high resolution.
Right.
I was reading that apparently we're on the dawn of having 4K resolution display, 10-inch form factor. It's not too far off. They're already getting ready for it. So.
Yeah.
But I mean, Tegra 4 can actually support, that resolution almost.
Yeah, Tegra 4, I think we have a demo downstairs that shows Tegra 4 driving a 4K TV, so it can decode a 4K video flawlessly.
Exactly right. You're very confident in saying that we can continue to increase performance, but at the same time we can get more efficient devices.
Right.
And this is technically possible,
Yeah, definitely, because process technology is continuously improving. Like few years ago we were on 65 nanometer,
That's right.
40 nanometer, 28, and we're going down. And these process technology improvements gives us more power efficiency, and architecture is also getting more efficient. Like we went from single core to dual core, and it's a well-known fact. More cores running in parallel, can run at lower frequency and voltage, and gives you better power efficiency. So I think that trend will continue, and as we provide more and more performance in these chips, people will start using up this performance. I mean, if you recall, a few years ago when NVIDIA introduced the first dual core mobile processor, people were wondering, do you really need a dual core in a smartphone? But pretty soon everyone moved to quad core because they realized we need this more performance. And as they use these devices more often, they want to use it like their own personal computing device. And
of course, and that's where we're going. I was speaking with ARM last night actually, and they were saying that within 2 years we'll have equivalent performance to what you're used to experiencing on your PC.
Could be, yes.
In terms of Android and whatnot, I mean, obviously I know NVIDIA is a big supporter of Android, but is it true really that Android can't take full advantage of this many cores? Is it, are the app developers kind of sort of lagging in a single core instruction set mentality?
Not really. I know Android, as you know, was based off Linux, and
Yeah.
Linux had support for multi-core,
Multi-core, yeah.
and Android today supports multi-core architectures. Like the operating system inherently is capable of scheduling threads across multiple cores.
That's true.
The web browser takes advantage of multiple cores, especially the Chrome browser that
Yes.
supports multiple tabs can like schedule threads for each tab on different cores, and like
I think you have a
deliver.
demonstration that can perhaps show something to that effect.
This is a web browsing demo. What we have set up here is this is a Tegra 4 development platform, and this is a Nexus 10 that is powered by a dual-core A15. And both these tablets are connected to a web server through wired Ethernet.
Okay.
And the reason we are going wired and the reason we are going to a local web server that is under this desk is to eliminate all the network latencies, the server load latencies, and just purely benchmark the capability of the these two tablets. So I'm going to launch this web page load test, and what this test is doing is it's basically loading up 25 websites, and these 25 websites are the top 25 sites that are most visited in the US.
Okay.
And we've ripped those sites, stored them on this local server, and I'm going to launch this test on the Tegra 4 and on the Nexus 10. And as you can see, Tegra 4 is really like loading these fast.
And the cache has been cleared.
The cache has been cleared. Everything is being loaded from the server, and Tegra 4
This is a dual core A15
this is
versus
dual versus quad A15.
quad core A15. So.
And so Tegra 4 will load these 25 pages in approximately 25 to 27 seconds, and you'll see that soon.
Silent gadget there.
Yep. So there you go, 27 seconds to load up 25 pages. That's approximately a second and a half. While the Nexus 10 takes anywhere between 45 to 50 seconds, delivering a 60 to 70% performance benefit on the quad-core Tegra 4.
Substantial improvement. So really, when do you think we're going to be able to see Tegra 4 devices in the wild at the earliest?
Q2 of this year.
Q2 of
Yeah,
this year?
yeah. ZTE and Toshiba already announced that
Yeah,
they're working
that's
with
right.
us to bring tablets
Okay.
and phones to the market, and you'll see more devices show up.
So we're looking at 57 seconds for the Nexus 10, the A15 dual core,
Yep.
versus the 27 seconds for the quad
It's
core.
almost 2 times faster.
And does it still have the fifth sort of Ninja core as Jetson?
Yeah,
the
definitely.
companion core?
Yes.
Okay.
So
Interesting.
yeah, Tegra 4 has this 4+1 architecture with the fifth battery saver core.
That's right.
So the battery saver core itself is a Cortex A15 core, but it has been optimized for ultra low power consumption. So for example, let's say right now it's sitting idle doing nothing. So we turn off all the 4 main cores and
That's
just
right.
run it off the battery saver core. And if the display is turned off and you're just doing social network syncs in the background or playing music,
stuff.
all of that runs on the battery saver core.
Nice.
And the fact that on Tegra 4 the battery saver core is Cortex A15, it's much more powerful, so it can handle more.
A lot more, eh?
Yeah, it can handle a lot more tasks in this low power state. And our the 4+1 technology is a second generation technology on Tegra 4, which means we get even more power saving because we have optimized the algorithms further.
I understand completely. Well, that's a nice thorough rundown. I'm completely sold on what you guys are bringing to market.
Thank you.
I really wanted to say thank you very much for your time.
That's nice
And
talking to you.
congratulations.
Thank you.
Nice to talk to you too. All right, it's Android Authority. We're going to sign off for today. We pulled an all-nighter last night to try and get you some videos online. We'll have lots more news on NVIDIA and lots more to come here from Mobile World Congress in Barcelona.